ELC1 Chemical or physical change. Solids, liquids and gases. If we want to put materials into groups, one way to do it is to group them as solids, liquids and gases. Deciding which group a material belongs to is usually quite easy, but not always. Jelly is a solid. We say that it is a solid because it keeps its shape unless a force acts on it, and it cannot be made to take up less space. Orange juice is a liquid. We say that it is a liquid because it fills up the shape of any container that it is put in. Like solids, liquids cannot be made to take up less space. They cannot be squashed. We usually experience oxygen as a gas. Gases spread out everywhere, and unlike solids and liquids, they can be squashed and made to take up less space. We can explain these properties by thinking of materials as being made up of tiny particles. The particles in solids, liquids and gases are a bit like the people at this carnival. The people who are sitting down watching are like the particles in a solid. They are close together and they cannot move around. The people who are standing up watching are like the particles in a liquid. They are close together but they can move around. The people who are dancing in the street are like the particles in a gas. They are more spaced out and they are moving around quickly. Changes of state. One of the problems with grouping materials as solids, liquids and gases is that most materials can exist in all three states. Water can be a solid, ice, a liquid and a gas, steam or water vapour. All three states can be seen in this picture. We usually experience gold as a solid, but it can exist as either a solid, a liquid or a gas. It all depends on how hot it is. The hotter a material is, the more energy its particles have. If the particles have enough energy, then they come apart and the solid becomes a liquid. Some particles have stronger forces holding them together than others. That is why some materials have higher melting points. Gold does not melt until it gets to a temperature of 1024 degrees. We usually experience oxygen as a gas, but again, like gold or any other material, it all depends on how hot or cold it is. The temperature of a material is basically a measure of how much energy the particles in that material have. If we take energy away from the particles, then they stop moving around so quickly and come closer together. A gas will condense to become a liquid. If oxygen is at temperatures that we usually experience in everyday life, it is a gas. If we cool it down enough, it will condense and become a liquid, just like steam or water vapour on a cold window. Usually, water condenses at any temperature less than 100 degrees. Oxygen condenses at any temperature less than minus 183 degrees. That is 183 degrees less than zero. So solids can become liquids, liquids can become gases, gases can turn back into liquids and liquids can turn back into solids. It all depends on the amount of energy that the particles have. It all depends on the temperature. Chemical changes. Changes of state are not the only way in which materials can change. Sometimes when the particles in two different materials have enough energy, they will join together in different ways and new different materials are made. This is a chemical change or chemical reaction. An obvious example is when gas burns in air. The atoms in methane gas and the atoms in the oxygen in the air put themselves together in a different way. They put themselves together as carbon dioxide and water. To get them to do this requires a bit of heat to start with, a match or a spark, but then, once the change is underway, a lot of energy is given out. Chemical changes or chemical reactions are happening around us all the time. Fuels are being burned, iron goes rusty, food is being cooked. Even living things can be thought of as huge collection of chemical reactions all happening in one place. Inside our bodies, old materials are constantly changing into new materials. The way in which we break down the food in our digestive systems is a collection of many chemical changes or chemical reactions. The important difference between a change of state, like ice melting, and a chemical change, like burning gas, is that when a change of state happens, no new material is made. Ice is simply water that is a solid. Change of state, no new material is made, easy to change back. Chemical change, a new material is made, not easy to change back. Another difference is that changes of state can be easily reversed. If we put water in the freezer, ice is formed. If we take the ice out of the freezer, it will melt. But if we wanted, we could simply put it back into the freezer and it would turn back into ice. It is very difficult and often impossible to make a chemical change reverse. It is very easy to cook an egg, but it is impossible to uncook it.